Hey guys, welcome to another video for 7A Math second quarter. For this week, we're just going to go over monomials, GCF and LCM. So be warned, this will be complicated and stress inducing. However, I just want you guys to get a taste of what are monomials and what you can do, how we can find the GCF and LCM of them. Because monomials will be important as you move on to higher levels of math learning. So, first of all, what is monomial? Well, monomial comes from the word mono, meaning one, and the word nomial, meaning term. So, in this case, monomial means a single term, no S, term. So, now we know what the monomial means. However, how do we make monomials? Well, monomials have three parts. It has a constant, it has a variable, and it has an exponent. The variable has an exponent, not the constant, by the way. Also, monomial can have several variables multiplied but never added or subtracted. So what does this all mean? What does it all look like when we put it together? Well, let's list some examples. An example of monomial should look like 7x. It has a constant 7 and has a variable x. However, you're asking to yourself, what's the exponent of this one? You said it needs an exponent. Well, if you recall, 7x is basically the same thing as 7x to the first power. Why? Well, again, recall, x to the first is the same thing as x. This is what we learned on 1.2. Now, what else? Well, we can also have 2mn to the third power. Do you recall what does this basically means? It basically means it's 2 times m times n to the third. They're all multiplied together, but we can shortcut it. We don't have to put the dots and smush them together to put 2mn to the third power instead of 2 times m times n to the third power. What else is an example of monomials? Well, 3x squared y to the fifth is an example of a monomial. Again, the variable can have different exponent, okay, for monomials. And what does 3x squared y to the fifth means is 3 times x squared times y to the fifth. Is there any more? Yes. X to the second power is also a monomial, but you might be thinking to yourself, wait a minute, where's the constant? Well, x squared can also be interpreted as 1 times x squared. However, we just don't put the 1 because it's useless. 1 times something is anything multiplied by 1. What do you get? You get it back. So you don't need to put 1 when you have an exponent, when you have a constant of 1. So what are not monomials? Well, 7 plus x is not a monomial. So does 7 minus x. Another example is 24 m to the third plus n. That's not a monomial. Another example will be 34 plus x squared plus y to the third. that is also not a monomial. Why, you might be wondering? Well, it's mostly because of this, symbols. The only way you can combine a constant and a variable with an exponent is through multiplication, not any other operation, not even division. Okay, monomials can also have, I don't want to say this, it might be confusing. So right, forget I was supposed to say something here, because probably get more confused if I do that. Anyway, hopefully you guys have no problems with monomials. Now, let's try recording some things first. So we talked about this at the very beginning. A variable x, it has an exponent of 1. So if you have a variable x, you should automatically think that, hey, there's a variable x with an exponent of 1. Okay? Now, we're going to extend this idea. Later on, there will be instruction where we're going to write variables with exponents of 1. So what do I mean by that? Suppose we want to write x to the 4th as variables with exponents of 1. What you're going to do is you're going to put x4 as x times x times x times x, because essentially all of this is x to the 1st times x to the 1st times x to the 1st times x to the 1st. That's what this means. However, we're just too lazy to put the x to the 1st, because again, math people are lazy. We always want to do shortcuts, and that's how math becomes simple, because people's laziness, essentially. Now, let's talk about factoring monomials. How do we factor monomials? Well, there's two steps. First, you want to write the constant of the monomial as a product of prime numbers. Hey, we learned how to do this. This is called prime factorization. So if you're still not good with prime factorization, well, here's another practice example for you guys. Now, the next step is, after you're done with the constant, we want to write the variable as exponents of 1. So essentially what we're going to do is we're going to do this. This is what we're going to do. We're going to put x to the 4th equals x times x times x times x instead of x to the 4th. Okay? Now, I have two slides here. Anyway, first thing is, let's have an example. In this example, we have 3x to the 3rd power y to the 2nd power. Or in other words, 3x cubed y squared. Again, there's a lot of ways to say this. I mean, there's only two ways. So, the first step is, you want to write the constant here, the constant 3, as a prime factorization. But the question is 3 already a prime factorization? Yes. So, we leave it as this. Now we put a multiplication dot. Why multiplication dot? Well, we have x's and y's here. So please put multiplication dot instead of the multiplication cross. Again, this is not addition, multiplication. This is why I'm letting you guys use your calculators, because multiplication. You will guys be bombarded with multiplication. Some addition and subtraction, but mostly multiplication. And calculator helps a lot. Okay, I'm going off topic. Going back, we have 3x to the third power y squared. Now, focus on since we're done with the constant, focus on the variable x cubed. X cubed is the same thing as x times x times x. Okay, now we're done with the x cubed. Now we move on to the y squared. This is simply y times y. And that's it. You're done. You simply rewrote 3x to the third power y squared as 3 times x times x times x times y times y. And you already factored them. Very simple. Now let's have another example. 6ab. Now, first thing first, you wanna do the constant 6 first. Constant 6 as a prime factor is 2 times 3. Then, you move on to the variable a. A is already a variable with exponents of 1. So, we leave it as is. Now we move on to the next variable, b. B is also the same, so we leave it as is. So we simply rewrote 6ab as 2 times 3 times a times b. You're putting multiplication dot in between all of them, okay? Now, let's combine what we learned. We have 28x y to the third. So the first step is, yes, uh, yes, uh, prime factorize find the prime factorization of 28. This is 2 times 2 times 7. Now moving on to the next variable, x. We leave it as is. Next variable, y to the third. We change y to the third as y times y times y. Now, hopefully you guys if you do have questions about factoring monomials, you can leave it you can email me, or you can just tell me on Google Classroom. Okay, moving on. Now that we learned factoring, we should also learn finding the GCF of a monomial. Factor the first step, there's 3 steps. Factor the monomials. Step 2, identify all the common factors, including the variables. Step 3, multiply all the common factors. Now, I found a short video explaining how you're going to find the GCF monomials. Probably better than my explanation. So, we're going to watch it together.
Let's find the greatest common factor of these 4 monomials. Well, to find the greatest common factor, the first thing we need to do is rewrite each one of these monomials in its factored form. In other words, we need to factor each monomial. So let's look at our first monomial, 6x squared y. 6, the number, can be factored in to 2 times 3. Then x squared is the same as x times x. Y is already factored as much as it can be, so we just write it down. Now let's factor our next monomial, 14xy squared. 14 can be factored into 2 times 7, then we have x, and y squared is y times y. Now for our next one, 42xy. 42 is 2 times 3 times 7. Then we have x times y. Finally, we factor our last monomial, 2x squared y squared. 2 is already prime, so we just write it down. Then x squared is x times x, and y squared is y times y. Now we've factored each one of our monomials. Our next step is to look at each one of these factors and identify which ones they have in common. So let's look at each one of these factors and see what they have in common. Let's circle the common ones. First, let's look at this 2. Is this 2 a common factor? Well, does 2 occur in every single one of our monomials? Yes, it does. We have a 2 here, 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 and here. So that means 2 is a common factor. So we circle it. Now what about 3? Is that a common factor? No, it's not. We have a 3 here and here, but we're missing it here and here. So 3 is not a common factor. Looking at x, we see that x is a common factor. There is one x in each one of our monomials. Now there's not a second x, so this x is not a common factor. Now y is a common factor. We have one y in each one of our factors. Now we've identified all of our common factors. The next step is to take these common factors and write them down in a list. To do this, just look at one of the factored monomials and write down any of the circled numbers. So let's look at this first one. We have 2, x, and y. So those are our common factors, 2, x, and y. But we're not looking for the common factors, we're looking for the greatest common factor. So to find the greatest common factor, we need to take all of the common factors and multiply them together. So if we have the common factors of 2, x, and y, to get our greatest common factor, we multiply them, and we get 2xy. So 2xy is our greatest common factor among these 4 monomials. Now there's one more thing to note about the greatest common factor. In our problem, we only had one x and one y in our greatest common factor. This is not always the case. If we had another x here and here, we would have enough x's to have a second x in our greatest common factor. Then we would have an x squared instead of an x. So remember, you can have multiple of variables or numbers in your greatest common factor. You just have to have that many numbers or variables in common among all of your monomials.
Thank you for that wonderful explanation, virtual nerd. Going back. So, let's have an example. Another example will be 16x squared and 36x. So, first thing first, as shown in the video, is you want to write 16x squared as 2 times 2 times 2 times 2 times x squared. Oh shoot, not x squared, my bad. It's actually x times x, while 36x is 2 times 2 times 3 times 3 times x. Now identify the common factors. You can circle them, I'm bad at circling, so I rather underline them. So the common factor are 2's. Anything else? Yes, there's another 2. And then we have an x. So next step is list. A lot of people does this in my class. However, they don't do the last step, which is multiply. And once you list their common factor, you multiply them 2 times 2 times x to find the GCF, which is 4 times x, which is basically 4x. 2 times 2 is 4, 4 times x is 4x. Moving on, another example, 32y squared and 6x squared y. So, let's rewrite them. 32y squared is 2 times 2 times 2 times 2 times 2 times y times y. 6x squared y is 2 times 3 times x times y. So underline common factors 2 and y. So you count, list them, 2 and y. So your GCF is 2 times y or 2y. Another example, 7xy to the third and 28x to the fifth y squared. 7xy third, 28x fifth y to the second. So if you list them, 7x to the y third is 7 times x times y times y times y, and 28x to the fifth is 2 times 2 times 7 times x times x times x times x times x times y times y. Underline common factors, 7's, an x, a y, oh shoot, not that x. So let's list them, 7 x and a y, another x, oh no, not an x, and a 7x and a y. So if you put them together, your GCF is 7 times x times y, or 7xy. Now, here's the main essence of a GCF. GCF, in other words, is the largest quantity that we can find that can divide both monomials. Monomials is monomials. So, as you can see, 7xy can divide both 7xy to the third and oh shoot, my bad, there's another y. So it's 2 y's. So it's 7x y times y, which is 7xy squared. And as you can see, it can divide both 7xy to the third and 28x to the fifth and y second. Why, you might ask? Well, if you look at closely on our exponents, we have 7. If is one higher, y to the third, do you believe that you can divide y to the second with y to the third? No, right? Because there's 2 y's there, and you have 3 y's here if it's y to the third. Same thing with the x's. If suppose you believe it's going to be x to the second, can x to the second divide this lonely x? And the answer is going to be no. So, has to divide both the numbers. Hopefully you guys are getting the hang of it, the GCF of monomials. So we're going to find the LCM of monomials. So the first step is factor the monomials. Identify all the common factors, including the variable. Multiply all the common factors along with the factors not selected. Sounds complicated, but once we see it, it's going to be kind of easy. It's not going to be super easy that it's like, oh, I got it, just like that. You need practice and practice and practice until you get the essence of how to find the LCM monomials. Let's start with an example. Let's start with easy ones. So we have 3s and s squared. So factor them, 3 times s, and s squared is s times s. Now find the common factors, s and s. So the LCM is basically what you're going to do is you're going to multiply all the factors, and you're only going to count the common factor once. So here is going to be 3 times s times s. It's not going to be 3 times s times s times s because you're going to count this pair of s. Going to count this pair of s as 1s. And if you put them together, 3 times s is 3s squared. Let's have another example, 14ab and 21bc. 14 is going to be 2 times 7 times a times b, and 21bc is 3 times 7 times b times c. So if you what the LCM is going to be the product of 2 times 7 times 3. Again, we're going to count 7 one time only, times a times b times c. B is only counted once, so we don't have double b's. Now combine them. (42) A, B, C. 2 times 7 times 3 is 42. A times B times C is ABC. However, this is the explanation of the book. Some of you guys will get it, some of you guys will not get it, and that's fine. There's another way, and this is my preferred way. Again, we're going to go back and watch a video.
Let's find the least common multiple of these two monomials. To find the least common multiple of two monomials, it's always a good idea to start out by factoring each of the monomials. So in our first step, let's factor each one of these expressions into their prime factorizations. First, let's look at 4x squared y to the fifth. To factor a monomial like this, it's always a good idea to look at the numbers and each variable separately. So let's start by looking at the number, 4. What can we factor 4 into? 2 times 2. 4 is the same as 2 times 2. And since 2 is prime, that means that 2 times 2 is the prime factorization of 4. Now let's look at x. We have x squared. Well, x squared is the same as x times x. X being multiplied together twice. Now we have y to the fifth. Well, y to the fifth is the same as y times y times y times y times y. Y being multiplied together 5 times. Great! Now we've taken this original monomial and factored it into its prime factorization. Let's do the same thing with our other monomial. We have 6x to the third y squared. Again, take each number and variable separately. So first we look at 6. Well, 6 is the same as 2 times 3. 2 and 3 are both prime. So that means 2 times 3 is the prime factorization of 6. Great. Now let's move on to those variables. We have an x to the third. Well, an x to the third means that we're multiplying x together 3 times. So we get x times x times x. Now we have y squared. Well, y squared is just y times y. Y being multiplied together twice. Now we've taken each of our original monomials and factored them into their prime factorizations. In our next step, let's look at these factors a little more closely. Let's go through and count the number of times a factor occurs in each factorization. So let's see. Let's start with 2. How many times does 2 occur in this factorization? Twice. We have 2 times 2. 2 occurs twice in this factorization. How many times does 2 occur in the other factorization? Once, right here. Now that we figured out how many times 2 occurs in each factorization, let's figure out the most number of times 2 occurs in a factorization. This will help us find that least common multiple. Let's see. We said that 2 occurred twice here and once here. So that means that the most number of times 2 occurs in a factorization is twice. So let's circle those factors to keep track of them. These two 2's. Great. Now let's do this for all the other factors. Well, in this factorization, we don't have any numbers left. But what about the other factorization? Well, we've already considered this 2 right here. But what about this 3? Here, 3 occurs once. But how many times does it occur in the other factorization? There aren't any 3's in the other factorization. So that means that the most number of times 3 occurs in a factorization is once, right here. So go ahead and circle that one lonely 3. Now let's move on to the variables. Here we have x's. X occurs twice in this factorization. In this factorization, x occurs 3 times. So we have 2 x's and 3 x's. The most x's we have in a factorization is 3. So circle those x's. Perfect. Now let's move on to y's. Here, y occurs 5 times in this factorization. Y is being multiplied together 5 times. In this factorization, y only occurs twice. So that means that the most number of times y occurs in a factorization is 5 times. So we circle those y's. Perfect. Now, let's look back at all the factors we circled. In order to find that least common multiple, we need to take all the factors we circled and multiply them together. That will give us our least common multiple. So let's see. We'll do our numbers first. Here, we have 2 times 2. Here we had 3, so we have 2 times 2 times 3. Then we had 3 x's being multiplied together, so we have x times x times x. And finally, we had these 5 y's, so we have y times y times y times y times y. When we multiply all these factors together, we will get our least common multiple. So in our fourth step, let's rewrite by multiplying all these factors together. Let's see, 2 times 2 times 3 is 12. X times x times x is x to the third, x being multiplied together 3 times. And here we have y to the fifth, y being multiplied together 5 times. Now we just need to put these all together. That means that the least common multiple here is 12 x to the third, y to the fifth. So now we have our least common multiple. The least common multiple of these two monomials is 12 x to the third, y to the fifth.
So wonderful explanation from Virtual Nerd. So if you guys having trouble, you can go here, or you can just YouTube other lessons. Excuse me. Anyway, going back. So if you look at the video more truly, you'll see some ironic situation. When we find LCM of monomials, we can try and looking for whatever occurs the most. And the word the most is the most important part. The most. Why the most? Well, do you forgot what is LCM stand for? It stands for the least common multiple. Least common multiple. However, when we're going to find the LCM, we can try and look for whatever occurs the most. You can also switch this around, and instead you're going to go to find the GCF of monomials. We can find the one that occurs the least. However, that's a whole another topic, and I don't want to go over that because it's too advanced and too mind confusing. Okay, now let's move on. Finding the LCM of 24d squared and 36d to the third e. So the first step is, again, always factor the numbers. This is 2 times 2 times 2 times 3. And then d is d. E squared is e times e. (36d to the third e) is the same thing as 2 times 2 times 3 times 3 times d times d times d times e. Now look for whatever occurs the most. So for the first prime factorization, we have 3 2's, and the second one we only have 2 2's. So the most occurring 2's is going to be the 3 2's. So circle that or underline them, or take note of them however you want. Now moving on to 3, on 24d squared we only have 3, 1, it occurs 1 time. On the second prime factorization it occurs 2 times. So the most times 3 occurs is 2. So circle that. Now we can ignore the numbers because is there any more number left? No, because the 2's in the bottom, that is already, we already did that, and the 3 is in the bottom is already done, and there's no more numbers. So we move on to the variables. Here we have, on the first prime factorization, we have 1d. On the second one, we have 3d's. So the most times d occurs is 3 times. So circle that. Now we move on to the next letter, e. Here, e occurs 2 times on the first prime factorization and only 1 time on the second one. So the most time it occurs is 2 times. Circle that too. Now put them together. 22 times 2 times 2 times 3 times 3 times d times d times d times e times e. 2 times 2 times 2 times 3 times 3 is 2, 4, 8. 9, 8 times 9 is 72. And double check just in case. Yep, 72. Now d is d to the third and e is e to the second. Put them together, you get 72 d to the third e squared. And that's your final answer. Let's have another one. And that's probably, this is the last one. So stay with me. We have 45 gh to the third and 33 g to the fourth h. 45 is 5 times 3, not 5 times 3, it's 3 times 5. Three times 3 times 5 times g times h times h times h. Well, in this case is on the second prime, 33g to the fourth h is 3 times 11 times g times g times g times g times h. Now find the common, let's count. We have 33, we have 2 3's in the top, and that's the one that occurs the most. Now we move on to the next number, 5. Here, 5 occurs 1 time, and on the second prime factorization, it doesn't occur. So 5 occurs the most 1 time. Circle that. Now we move on to the next factorization, 33g to the 4th h, before we do any letters. So 3 is already done. We did that already. The next number 11 we didn't do, so let's try. 11 occurs 1 time on 33 and 0 times on 45. So the most times 11 occurs is 1 time. So circle that. Now we move on to the letters. Again, we're going to do the first factorization. So G occurs 1 time on 45G H third and 4 times on 33G to the 4th H. So the most times G occurs is 4 times. So circle that. And then moving on to the last letter, H, our variable. H occurs 3 times on 45G H to the 3rd and only 1 time on the second prime factorization. So H occurs the most 3 times. So circle that. And then put them all together. You get 3 times 3 times 5 times 11 times G times G times G times G times H times H times H. Now focus on the numbers. 3 times 3 times 5 times 11 is going to be 495. Now G times G times G times G is G to the 4th, and H times H times H is H to the 3rd. Combine them, you're going to have 495 G to the 4th, H to the 3rd. And that's it for finding LCM. So if you guys kind of get it and still not get it, don't worry. Monomials will not be counted as your grade. Your homework will be a survey. Anyway, however, I'll probably throw in some extra credits on the quiz using LCM and GCF of monomials. So take notice of that. Anyway, hope you have a wonderful week. I'll see you on the next video. Goodbye.